Hello, guys.
Hello.
Hello.
Well, I hope you had a nice week. First thing, let's start speaking about the homework.
Yes, the deadline is Sunday evening, right?
Yes. So I guess you guys didn't start on the homework yet?
Yes.
How about the others?
Just looked the assignment.
So I guess just to help you guys a little bit more, I will read basically the homework assignment again and explain it to you, just so that when you start, it would be easier for you to understand what to do, okay? Let's open it. Correct. Share screen. There we go. So the homework task is very simple. I hope you guys can see the screen.
Yes.
Yes, we can.
So the homework task is very simple. The deadline is in 2 days. What you will be doing is you will train different models, namely decision trees, logistic regression, support vector machines, naive Bayes, and KNN. And you will train them on the dataset called load digits. So this is a dataset of digits from sklearn. Let's check it out. Yeah, it looks like this. So this is the dataset. And you will have to basically train a model that can recognize this as a 0, this as 1, this is 2, this is 3, so on and so forth. So this is basically your task. What you will be asked to do is to submit basically a Colab link with the code for training all of these models and basically evaluating them, doing the test, doing the train test splits, understanding or explaining how overfitting and underfitting work for each one of these models, and basically write a report about the techniques used for pre-processing the data, train test split, how did you do it, how did you use grid search CV to get the best results for each model, and basically explain how to change the hyperparameters of each one of these models to fix the overfitting and underfitting problem. Do you have any questions so far? The grade would be 50% on the Colab link, so basically on the code, and 50% on the report. Preferably, you should write the report in Overleaf, if you're already familiar with it. If you don't know what Overleaf is, then you should just use some Google Docs or something like that. Okay?
So we can use Google Doc or we should use our link.
No, you can use Google Doc. Yes, you can use Google Doc.
Oh, okay.
Anybody else has some questions? I think not. Very nice. So before we go further with the lecture, as you know, we will have a quiz about neural networks after a few minutes. So just if you have any questions, if you have anything to ask, to clarify about neural networks and the things we have seen in the last lecture. I see there are no questions. So let's get through a small revision for neural networks and then start our quiz right after. So again, neural networks consist of different neurons in every layer, and then we have different layers inside that neural network. The connections between the neurons represent the weights that connect these neurons, and every neuron basically is a logistic regression application, right? So it's very similar to what we have seen in both linear regression and logistic regression. All that it is doing is just multiplying some weights by the input, summing them, and then sending it through an activation function. The activation function that was easiest to use or the most commonly used is sigmoid, but we have seen that there are other activation functions such as ReLU and tonnage, but ReLU is the simplest and the fastest to train. So a layer in neural networks is a group of neurons that is connected with the same inputs. The neuron does some mathematical function very similar to logistic regression. And we spoke about gradient descent, which is an algorithm that trains the neural network or that learns the values and the weights of the neural network by minimizing the error of the output or the error of the predicted output of the neural network. As we have seen, a gradient descent works by calculating the gradient at the current point and then taking a step forward in the direction of that gradient in order to minimize the loss function. So this is overall what we have seen previously in the last lecture. If you have any questions, please feel free to ask. If you don't, I will make the quiz visible for you guys. And we should start around, let's make it 52. You will have 10 minutes. Do you have any questions?
Not yet.
Хорошо. So I hope you guys can see quiz number 4 in Moodle right now.
Yes, it starts in 2 minutes.
Хорошо. Once the quiz starts, you will have, I think, 13 minutes to finish it, but the total time will be under 10 minutes. So you can start exactly when it opens, or you can start a bit later. There's no problem in that. Okay? Is there somebody who cannot see the quiz? Nice. Okay, very well. You can keep the lecture notes open as usual, but you cannot cheat from each other. So try to answer it alone and basically use your lecture notes to verify your answer. It started.
So we can start, right?
Yes, yes, you can start. Go ahead.
Is it right that we can see our results after execution?
You shouldn't be able to see the results directly, right? You should be able to see it after we finish the exam. Can you see the results so far?
Yes.
I don't know why, but let me fix this. Now it should be fixed. Thank you for telling me. See? No. I can see that some of you already finished. That's nice. There are 2 minutes left, guys, so try to finish quickly. I see there is somebody new who just joined. If you haven't started the quiz, then you should try your best to start right now.
By the way, we should either not allow to do it again, I mean, reattempt, or just not show the result in the end.
Yeah, that's true. Usually I remove the ability to see the mark before the end. But for this one, it was not saved. So for that, you guys could see it.
Okay, because I tried to do it again and it's work. So it's-
You got like 100%?
I think yes. I don't see results.
Let me see the results. Overall, the results are not very bad, but could be improved definitely. Let's go to the quiz and try to answer it together. Results preview. You guys can see it? You guys can see the screen, right?
Yeah.
Nice. Neurons in a neural network perform the same or a similar operation to logistic regression. Yes or no?
Yes, it's true.
No. Adding more layers into a neural network allows it to learn more complex decision boundaries. True or false?
True.
Nice. Does anybody have any other answer or something like that?
It might be false.
Yes, if you think it is false, can you explain?
So I don't think it's false, but it can be. You ask what can be answers, and I guess
It
it's true and
is
false.
true.
Just that.
It is true. The more complex a neural network it is, the more complex its decision boundary, right? So you can think of it like this. The simplest neural network is logistic regression, right? Just one neuron. This is the simplest neural network. The most complicated neural network is here. So here we have a simple decision boundary. Simple means it's linear, right? Complex means it is highly non-linear.
But in case if we have a lot of simple linear neurons, we have a complex but linear neuron.
True, but that's why we use what? Activation functions. We will get to this question later on.
But adding more layers not always leads to learn, not always allows to learn more complex decision boundaries.
What do you mean?
Okay, I'm not sure, but okay, let's go further.
No, there is a difference between learning a complex decision boundary and getting good performance. There's a big difference between these two. A complex decision boundary, it means, let's draw it here. So for example, this is class 1 samples, right? This is class 2 samples. A simple decision boundary would look like this, right? Very linear, simple. A complex decision boundary would look like this. So this is a complex decision boundary. It's very complex, but does it give good results? No. So the question is, when you add more layers to your neural network, does it become more complex or simple? More simple. Is it clearer now?
Yes, clear.
хорошо. Adding more neurons to each layer allows the network to learn the data better.
Yes.
True. Basically, you can think of the size of a neural network onto two aspects, right? How many layers, the number of layers, and how many neurons. If you increase the number of neurons or you increase the number of layers, you always get a more complex, neural network. It doesn't mean that it is better in performance, but it is more complex, right? So this one is also true. This one, adding a lot more layers makes the neural network suffer from high variance. Again, it's the same question, but presented in a different way. High variance means it is overfitting. Overfitting means the model is too complex, right? So again, it is the same question, but presented in a different way. So adding a lot more layers makes the neural network more complex. True, meaning it will suffer from high variance. It will suffer from overfitting. Activation functions allow the neural network to learn non-linear features or concepts from the data. This is true. Great. Activation functions don't need to be differentiable.
False. Maybe.
Exactly. Since the training of the neural network is done by gradient descent, and calculating the gradient is depending on the differentiation of the function. So the overall function of the neural network should always be a very differentiable operation, right? And hence, activation functions must always be a differentiable operation. Let's finish the attempt. Very well. Now I will open the grades again for you guys to see them. Can you guys see the grades right now?
Yep.
Yes, we can.
Nice, very nice. Do you have any questions so far? So right now we will go back to the same lab and try to understand it better and basically finish the lab completely. Once we finish this lab, I will give you probably for your next week the second homework assignment, which will be very similar to the first homework assignment, but in this case, you will not be working with a small data set. You will be working with a much bigger data set, and you will be training not only machine learning models, but you'll be training something much bigger, such as a deep neural network. So just to do a quick recap, we have seen what is the difference between artificial intelligence, machine learning, and deep learning. So artificial intelligence is a big field. Machine learning is a subfield of artificial intelligence, and deep learning is a subfield of machine learning. We see that deep learning has a lot of applications, especially the generative adversarial networks application, which is the most widely used, and it's the reason why now it's very popular. And of course, its abilities to process natural language, which is much better than that of any other model. So here we have seen a little bit what are the different, what is perceptron. We spoke about weights and biases, some other information here that you guys can look at. And we spoke about the different activation functions that we need. We need two things mainly, which is differentiable activation function and of course a nonlinear activation function. We have, these are the most famous ones, but if you will be doing any training, always use ReLU. It is very simple, very fast, and easy to use. Perceptron. So this is the example of neural network. For those who would like to understand more about the, what are they called? The mathematics behind the neural networks and how the training is done, you can check the, what are they called? These 3 Blue 1 Brown channel, or you can check Andrew NG courses, which are amazing, to be honest. We said that there are mainly 5 top frameworks for deep learning, and the 2 most famous ones are PyTorch and TensorFlow. For our purposes, we will be working with PyTorch. And basically, the TensorFlow 2.0 is just like a mimic of PyTorch. Model design in PyTorch. So here we will be speaking about the coding part, right? So I want you guys to like make a small checklist for every neural network you build, right? So the checklist contains the following 3 elements. Element number 1 is basically the data processing and data loading part. The second element is the models, the components, and the relationships between these layers. So basically, we define how many layers in this, how many neurons in this layer. This layer is connected to this one is connected to this one. What are, for example, the activation functions of this layer? What is the activation function of this layer? So this is step number 2. And step number 3 is basically how do we do the training of this neural network. Sorry guys if my voice is a bit like not very clear. I have like a small flu. I hope that you guys can still understand me though. I guess you can. Can you guys understand me clearly?
Yeah.
Okay, my voice is not that bad. Nice.
Yes.
The first step, which is the data loading step, usually what you should focus on are 3 elements in this step. The first one is the data source. As I said, usually since the data is no longer, so previously with machine learning, we were working with data sets in CSV format, or for example, Excel spreadsheets. Usually it's a small data set in one file, maximum 20 megabytes, right? But in the case of deep neural networks, they require a lot more data and they work with data in different formats. So for example, you'll be working with millions of images or thousands of videos, or even, for example, audio files and music. And hence, the data source problem becomes specific for each project, right? So it's no longer, as we did before, just pd.read CSV or read Excel. Now it's going to be a more complicated class and with its own logic. So for example, if you have a set of images which are broken down into different folders, then you will have to write the Python code that goes to every folder and find the images and load them to the model. So basically the data source part is very important and it's actually the thing that takes the most time usually in industrial projects. The second part in the data loading process is the data transformation part. Usually, as we have said, neural networks require a lot of data to train. And sadly, since we never really have enough data to train a good neural network, this is why there are like different techniques to improve the performances of these neural networks, including these data transformations. So let's just take a look at them. For example, argumentations. This is a very good library that I like to use. Okay. The demo. Here the demo. So basically what it will be doing is it will apply some changes to your data in order for the model to feel like he is learning from more images, right? For example, grayscaling, adding some noise. You see? Swapping it, making some cutouts in the image. You can increase, for example, the number of holes like this. We can flip it. So this allows the model to basically learn more from the same data. How do we usually do this? You'll find that there is like a lot of code that you can just copy paste directly. So this is the example, PyTorch classification example. And all you will have to do, for example, in here. So basically there it is. So this is what you have to apply. Self.transform over the image. And basically the transformation is defined as follows. There it is. Train transform equals A compose. And basically you send the list of transformations you would like to apply after each other. So for example, here the smallest max size. Can you guys still hear me? I think my internet is breaking a little bit for some reason. Can you guys still hear me?
Is augmentations like an example of library?
Yes,
What?
this is another library that can do very good transformation. I'm getting this error that's telling me that I have bad internet connection for Zoom. So if you notice that my screen is not very clear or something, please inform me, okay? So here we can see that there are different augmentations.
Okay.
Thank you. There are different augmentations, for example, shift, scale, and rotate. So this allows you to shift the image, scale it a little bit, and basically rotate it at the same time. You can apply a random crop on the image. You can play around with the RGB channels. You can change a little bit the brightness and the contrast of the image. And basically the final step is to normalize the values of the of the pixels to be in this basically range of between 0 and 1. Nice. Let's go back here. Now the final part is the data loader part. So the data loader part usually is pretty simple. So it just defines basically how many, for example, if you're working with images, how many images will you load to your GPU or will you load to your RAM at the same time? Basically, this is just to make sure that your RAM does not get over flooded with samples, as we have said, that the data set sizes now is not just 1 megabyte. It can go up to, for example, 20, 50, up to hundreds of gigabytes for a small project even. So this is why you cannot load the dataset directly to the RAM or to the GPU. And this is why they use different like batches. So instead of sending the whole data to the RAM, you send, for example, 16 images to RAM, train on those 16 images, and then go back and bring 16 others, train on those new 16, and repeat again and again and again until you finish the dataset. So this is what we call in here the batch size. How many images do we load from the data at the same time, right? We load 32 images from our data. I think in Colab, it gives us very good RAM and GPU. This is how you activate the GPU. So it basically runtime, change runtime type, and basically choose GPU from this thingy. And I think since the images we are working with are smaller in size, we can go to, for example, 64 images, right? At the same time. Next. So now it will be downloading the data. So this is what we called before as the data source. So you can see in this case, the data set already exists in PyTorch. So PyTorch has already written the code for us. But if you want to work with your own data set, which is most likely going to be the case, then you will have to write a similar code to this one. Basically, you will see it soon. Don't worry. not good. Okay, let's just load it from here. Six. For example, this topic. Select faces, say bar, cities, papers, cocoa, open stuff. Amist is the simplest. Now we go to the source code, and basically this is how it would look like. So you're gonna have to create a new class that extends this vision dataset. So this is just code for, this is just comments, ignore them. And basically these are the links for the downloads. Don't really focus on this too much. Basically, what you will be doing is the following. You will have to create basically the init function and basically do the load data. Yes, you have to implement this get item function based on the index. So basically, in this case, you have to load the data from the hard drive, and here you will have to read every image manually from the hard drive, and you will have to implement also this other function called length. All the other functions are here just for simplicity, just for basically programming reasons, and you can add as many functions as you want. But the two most important functions that you need are get item, which basically reads one image from your hard drive, and the length of the data set. This one should return how many images do you have. All the rest is just basic Python programming, and it depends on you and how you want to read your data. Now it is downloading the data, so you can see that the data set is quite large in size. Is downloading it. Use some data. You see, honest, raw, and there it is. So this is the training data. So now it should be training, downloading testing data. Right? For some reason, it is slower than usual. Let's continue, and it will finish the download soon. The transformations, for simplicity, in today's lab, we would not put lots of complex transformations, but then again, all you have to do, as we have said before, basically just create this list. And here, instead of only 2 transformations, you can put as many transformations before as you want, right? The data set, very simple, as we have seen in the case of a data set such as MNIST, but if you have a new data set that you have created in your own company, then in that case, you would be forced basically to write the code that we have seen before from scratch. Do you have questions?
No.
Okay, nice. The data loader part, again, as I said, only matters one thing: how many images will you be loading to, let's see, refresh. So this is our data set. It's contained in a list of what are they called? JZ, what are they called? Those things that zip files, yeah. It's in a list of zip files, and basically you will do it from there. And the data loader, what it does is simply basically load or decide how many images will we load to the RAM and the GPU at a certain time. Here we can see the second part, which is the models components. And for the models components in here, we usually break it down into two different parts, right? So previously we had the data reloading part, which is broken down into three parts. Now the models components are broken down into two parts. The first part is what are the layers of the neural network. The second part is the structure of the neural network. So basically the order of the layers and definitely the type of activations in each layer. So here we can see in the init function, which is the constructor function, we create our different layers. There are different types of layers in neural networks. For now, we are using the simplest type of layers, which are the linear layers. So basically, they are very similar to logistic regression or to linear regression, as we have said before. And what we do is we just define the size of the input, as you can see, 28 by 28, which is the size of our images. And basically, this is how many logistic regressions will we apply at this layer. This is how many logistic regressions we apply at layer 2. So this is 250. And then the last one is 100 logistic regressions. The second thing is the forward function. So this one defines the logic of your neural network, or basically defines the order of the layers of your neural network. So here we see, we take the data, we reshape it in the correct size, and then send it through the first fully connected layer. We send it through the ReLU activation function. As we have said before, these are the different activation functions, and we have seen that ReLU is the fastest during training. We do the same thing, so basically the output of the first layer goes to the second, output of the second goes to the third, output of the third layer goes to the fourth. And basically, we apply this log softmax activation function. We will speak about log softmax activation function in the next lecture, but just understand it is very simple to sigmoid. It is in fact, it is in fact an extension of sigmoid that doesn't work with only one class, but basically works on different classes, right? So you can think of softmax as a sigmoid, but for multi-classification purposes. And we add log softmax instead of softmax directly because it basically makes the, what do you call it? Makes the training faster. It's just a mathematical trick that makes the training faster. At this point, we are sending our data to the CUDA. So we are checking if we have SGPU available. If we do, we send our data there. So let's check it. For example, here we can definitely see that we have a CUDA device in our Colab environment. And what we do is we send the model through that CUDA device. And now we are just defining some hyperparameters. So we have finished the second part of defining the model's components. Now we start by defining the logic of the training. So before we do that, I just want you guys to see, for example, what are the different hyperparameters. So for example, here we see batch size for the training data 64, batch size for the test data is 1000. This is just to show you that you can put whatever you guys want. As you can remember, the batch size, we already specified it in this section, so we don't really need it in here, but you can also define it or change it in here. the number of epochs. So this is how many times do I see the whole data set again and again. So basically what we do is for every picture, we don't just train on it once, we train on the same picture for 10 times, 20 times, or however many times we want. The learning rate is the step size that is taken with gradient descent. So if you guys remember what we have seen last time about gradient descent, for example, here and here. So it's basically this size, right? So the size of this angle, not angle, but the size of this step. So basically the gradient only defines the direction. The learning rate defines the step size. And these are just some hyperparameters for the gradient descent. This one just for reconstruction purposes, don't even look at this. And this one is just for visualization purposes. Now the important part is these two functions. The first function here is called the train function. And the train function, basically, we give it the model, we give it the device, whether it's CUDA or CPU, we give it the training loader, which will give it the data set, and we give it the optimizer, and this is just the number of the epoch for visualization purposes, just so we can print the results of the number of the epoch we are in. Right? What we do is we set model.train. So this function call of model.train tells the neural network to start calculating the gradients, right? So basically, if we send input to the neural network, it will start calculating the gradients of those inputs. It also does some other processing, but we will speak about it in the next lecture when we speak about more complex things you can do with neural networks. Now, this is the main logic, basically, right? So this is how you can go through the data using the train loader. So basically, you put it in a for statement. For this is the index of the batch. This is the data set. These are the classes, and we are enumerating through the train loader, right? This allows us to get basically the data, as I said, and the targets. We first send them to the CPU or to the GPU using this toDevice function. Optimizer.zeroGrad is very important. It's not very important for simple neural networks, but it's important when you start working with more complex neural networks, especially when you are working in a system that doesn't have just one neural network, but has, for example, 5 or 6 neural networks that are working with each other. And sometimes it's easy to make small bugs in the code, and basically some parts of neural network A might influence neural network B. So this is why it's very important to put this optimizer.zeroGrad, which kind of removes all the gradients that can potentially be computed before starting our training process, right? Now the simple part is, as usual, we take the data, put it through the model, we get the outputs, we calculate the loss between the output of the neural network and our Y or our target or our labels. And basically, we calculate this loss dot backpropagation. So basically, this one calculates the gradient. Optimizer.step takes a step in the direction of the gradients. Step size of learning rate. This is just for visualization purposes, right? So just to see that we are doing things. The testing function is very similar. So first we have this model.eval. So it basically informs the neural network that we are not doing the training, but we are doing the evaluation part of our process. And here we are just calculating the average loss and average accuracy. What needs to be noticed is, again, we are going through the data in this for loop, as you can see, send it to the GPU or send it to the RAM. Then we send our data set to the model. We get the output. We calculate the loss between the targets and the output of our model. And basically, we calculate how many correct predictions are made by our model. So this is just some optimization that you can do. But if you guys want to do it in more like Pythonic, easy to read code, you can easily do that too. So basically, this is just a comparison between the outputs and the targets. And yes, this is just for visualization purposes. So let's see how the training is done. For every epoch, we do training, and then we see how the results are on the testing dataset. So let's come here and start. So we can see that in the start, for example, this is epoch 1. We have seen, for example, 640 images. The loss is 2.28, and we can see that the loss function is going down, going down, going down as we are learning more and more. Right? You can see that the loss function is going down and down. So here we can see the accuracy, which is 92. And here we can see this is the loss over the test data, which is 0.26. We will see that the loss will continue going down again through the epochs, and the accuracy is going up, the loss is going down, right? The more we train, the accuracy goes up, the loss goes down, until we arrive to like a certain place where there is nothing more we can do. So for example, here we have 97%, it's still improving, still kind of improving. Well, definitely improved a lot here. 98%, very well. Yeah. Now you see, we were in 98% at this step. After we continued training even longer, our neural network started overfitting. And this is something that happens a lot in neural networks. If, for example, I make the number of epochs to 1000, after 1000 epochs, the neural network will be super complicated and will be very, very overfitted. So it's always very important to keep an eye on how is your accuracy progressing through the training, how is your loss function progressing, and all of this information. There's already a very, very easy to use tensor board. So this is just a dashboard that basically tracks the loss values, tracks the accuracies, all the other metrics for performance. And you can see how they are changing during the training. And like this, you will be able to make more informed decision on what to do and what not to do. Do you guys have any questions so far?
We cannot define the number of epochs for training the model. We always must set it to maximum, right? As
You can
possible.
set it, preferably, yes. What you should do is simple. So I usually like to set it to a big number, for example, 50. I let it train, and then it will give you this something like this, right? So it will give you accuracy start to go up, 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 up. For example, you arrive to epoch number 20, the accuracy starts to go down, 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 right? So after I finish the training, I see that the best accuracy was on epoch 23. So what I do, I simply change the number of epochs to 23 and restart the training again. Okay?
Yes, okay.
Do you guys have any more questions, maybe? Is the code clear for you guys? So for example, this SGD, this is stochastic gradient descent. So it's the thing that we have seen before. If we go to Optim here, so we can see that there are many algorithms that can be used. Preferably use always Adam. So Adam is basically the best one that there is. For the case of this lab, we're just wanting to start the introduction. Hence we use SGD, but if you want something better results, go for Adam. It's better. So,
And
any questions?
and what do we have next?
What do we have next? So for this lecture, I was hoping that you guys would have already started working on your homework. So I planned basically that I will be looking at your homeworks individually and basically trying to fix some of the bugs in your code. But I hope that some of you guys have already started. Has anybody started or?
Yes, we started.
You started. Can you tell me, do you have any difficulties? If there's something that is not clear for you? Mm-hmm. I would like to give you basically this time to start right now on the homework and basically at least get to know who are your teammates and start working together while I am with you. So do you have your teammates with you in here?
I think we all were our teammates. We already divided, so.
Okay, so everybody knows who are their teammates. It would be nice if you start right now. If you want, I can stay with you guys while you work, or if you want, you could take a break and start working later on, and basically just send me messages about the homework. The homework is not simple, so it does take a lot of time. First to code it, and second, even if you have the code, it will take you around like half an hour to execute the code. So this is why you guys have to really start as soon as possible, okay?
Okay.
Nice. So again, if you guys don't have any questions for now, I think we can end this week's lecture right now and basically start on your homework as soon as possible and forward to me any of the questions that you have. Make sure that at least you have the coding part already set up, okay? try to do it by tomorrow maximum, right? Because the report also will take some time to write.
Excuse me, we have a deadline for tomorrow, for a Sunday, 23:59, right?
Yes,
Okay, thank you. And we should submit it in your private messages?
I will open the submission on Moodle.
Okay,
Let me open it for you guys right now. Add an activity. Assignment. Homework one. Allow submission of the plan now. Due date is 27th June at 23:50. Nice. Online text. So again, what you should submit is very simple. Submit the link to Colab Notebook and submit the link to the report in Google Docs. Every member of the team should submit separately the same content. There you go. Can you guys see it now?
wait a moment.
Yeah, I can see.
Very well. If you guys have any questions about it, please send it to me directly. Don't wait until like you are stuck and basically it's too late for you to submit the assignment. Please start on it right now and send me all your questions and bugs if you have, okay?
Okay.
Okay, good luck, guys. Have a good weekend and try your best to finish it as soon as possible.
Thank you.
Thank you for the lecture.
Thank you.
Thank
Bye.
you. Bye-bye.